Hi, everyone. It's great to be back at Upstream. I'm delighted to return. Thank you so much, Tidelift, for inviting me to give this keynote. It's a talk that I've been wanting to give for quite some time. And it's been a great opportunity to coalesce my thoughts into something coherent. So without further ado, this is how we treat others is a supply chain issue. But before we get started, as is my custom, if you would like to follow along on your own computer, you can see these slides and the notes that I've written for the talk at bit.ly/humans-in-supply-chain. It's a mouthful, I know, but what can I say? I like words. So, we're talking about supply chain issues, and it's likely that the phrase supply chain is not new to many of you. But I'm hoping that this will put a little bit of a different spin on things. A bit about me. My name is Julia Ferraioli. I am kind of a generalist in open source. I'm an engineer. I have done advocacy. I've worked at open source programs offices. I've done research. I do what needs to be done. And most recently published a paper on research practices in the ACMQ. So I'm really excited about that. I'm also the co-founder of Opensource Stories, which is a community kind of grassroots narrative project to elevate the experiences and voices of people in and around open source to make them more visible. If you know me, you know that I love two things starting with L. Well, three things, including my dog. LaTeX and Lego. Most of my discretionary income goes to Lego, which probably quickly outpaces the space that I have for said Lego. Luckily, LaTeX takes up much less space, at least physically. So, and one of the kind of unique things that I bring from my very varied experiences in my career is that I find a lot of weird corner cases. And the ones that I particularly like are the intersections of technology and humanity. And in this talk, hopefully, we'll see that they aren't edge cases at all. So, everyone's talking about the software supply chain. Weird voices aside, it does kind of feel like it has a bit of a Schoolhouse Rock vibe. Everyone seems to be talking about the software supply chain. And you hear it in the news, you read articles about it, you have conferences dedicated to it, you have companies springing up around it. It is everywhere. But the truck asks us, what is the supply chain? Everyone seems to use it so differently. And it's true. And some of this comes from the fact that supply chain is not actually a software term. Supply chain goes back to just manufacturing, how companies or producers get their goods to build other products. And we've kind of co-opted it for software. So if we look at a couple of definitions, if we go to our technology standard Wikipedia definition, it says the composition of the components, libraries, tools, and processes used to develop, build, and publish a software artifact. Now, software artifact is a kind of general term, right? It could be a library. It could be a fully fledged application. It could be a bash script. And similarly, components, libraries, and tools and processes are all fairly nondescript as well. I like the inclusion of processes in here because it does reflect on, okay, well, how do we actually go from point A to point B? It's not just the build system. It's also talking about how we track bugs, etc. Sonatype has a different take a little bit. It says anything that impacts the evaluation, production, and distribution of software. And that goes like a little bit before the Wikipedia definition. That evaluation piece is new, right? So how do you determine what software to use? How do you determine what dependencies to take? How do you evaluate the other pieces, other components, libraries, tools, and processes that you use to build and deploy software? GitHub throws the kitchen sink at it, which I think is reasonable. And it's anything that affects your software, period. So that gives us a lot of room to explore. But what I have found in talking to people about the software supply chain is they tend to use it as a shortcut to mean the piece of code, infrastructure, or system that I can blame when things go wrong. If things didn't go wrong, people wouldn't care so much about the software supply chain. And before we continue, a couple of notes about the terminology that I'll use here. So supply chain, as I mentioned, isn't a unique phrase to software. However, this is a software conference. When I say supply chain, I'm going to be referring to the software supply chain. And moreover, because I'm an open source person, and this is an open source conference, I'm going to actually mean open source software supply chain. So if you hear open source software supply chain, or just supply chain, I mean the same thing. I'm talking about the open source software supply chain. So the supply chain, space, open source software, it's a big business. A lot of people and companies are finding value in providing value to other companies around managing their supply chain. And it's blossomed, right? So we see a lot of people wanting to leverage other folks' expertise around the matter because it is complicated. It is a big beast of an issue to tackle. So we'll do a quick overview of some existing efforts around managing the software supply chain and managing issues within the software supply chain. So the first one is one you've probably heard about if you've been following the news, or if you're involved in cybersecurity conversations, and that's the software bill of materials, and commonly known as SBOMs. And that's basically your ingredient list for what goes into making up a piece of software or a library or. And the idea is that, if everyone in your software supply chain has their own SBOM, then you can easily compose them into your own for your final product. And it's a nice bit of transparency for the consumers of your code, of your product, etc. Hardened images are another one. So when you are building a product with that base image, is it secure? Is it stable? Etc. I know less about that part than others, so I won't go into too much detail there. Another one that people are offering as a service is the idea of software catalogs. So this can mean anything from pre-approving third-party or open source software that's available for use within an organization, a company, a department, etc., to specifying exactly what versions they can use, or making sure that they're compatible with each other. And so maintaining those catalogs is actually, if you maintain your own dependencies, you know how much work that is. And so there's a lot of value that people are finding in this idea of having someone else go through and vet the software. And vulnerability scanning. This is your antivirus for dependencies, right? And this one is complementary to the software supply chain. So can we scan for vulnerabilities, known issues, etc.? This isn't a comprehensive list, but gives you an idea of some of the existing efforts in the space. If we understand the software supply chain, we also understand how things are made, where they come from, the provenance of them, so that we can fix them when they break, and ideally prevent them from breaking in the first place. Are there issues in our open source software supply chain that we experience today that we can actually prevent from happening? And there's a lot of effort going on right now towards that end. Things like making sure you have succession planning in place for an open source project, which is very controversial, actually. 5 years ago, we weren't really talking about this. Most of us weren't really talking about this. And so if it does feel like this kind of came out of nowhere, it's not just you. You're in very, very good company. It does feel like this all of a sudden became an issue. But it's not, strictly speaking, true. We've been kind of heading this direction for quite some time now, towards software's boiling point, as I like to call it. And there are a lot of reasons for that. One of them is we use tech and tech products a lot more than we used to. I'm looking for a new refrigerator. It is hard to find one without Wi-Fi, without its own like open source license disclosure, which is great. I love that refrigerator companies have to now disclose the licenses that they use, or the open source projects that they use. But oh my goodness, it is in everything. It's really, really hard to buy anything that doesn't have technology embedded into it. And these are things that people buy. They're durable goods. People buy with the hopes of keeping for 5, 10, 15, 20 might be optimistic years. And when we think of the pace at which technology keeps moving forward, it's kind of incredible, right? And alongside that, we're releasing more open source software than we used to. It's more accessible because of the platforms and the tooling and the communication and the communities that we have around open source. And this has made it more accessible to folks. We have been able to have more projects created, more ideas set out in the wild to thrive, to explore, etc. And I think that's a good thing. Like, the next big thing, we just don't know where it's going to come from. It's going to come from somebody messing around, trying things out, and hopefully doing it in the open. And everyone is using more open source than ever before. Companies are migrating off of proprietary systems and looking towards open source instead of necessarily developing expertise outside their core business. And it's gotten a lot more complex as well. I won't say complicated because of the negative connotations around that word, but it's also gotten that too. But we'll say complex. We used to have maybe like a handful of commonly used complex open source projects. And now we've got tons of them. And what's more, they're relying on each other. So the complexity space has just gotten way, way more complex. And the number of companies that are also relying on these increasingly complex projects, that number has gone up. It might be showing my age here a little bit, but because of the complexity wrapped in lemon garnish or something, we've had kind of a reemergence of DLL hell as dependency hell. meaning I don't know what I'm depending on because it's buried deep in 3, 4, 5, 10 layers of node dependencies. And so it gets pretty difficult to unravel. But why are we really talking about it now? Why all of the attention all of a sudden? Well, failures of technology have become more apparent. It's not that they weren't happening, but they're more apparent now than they have been ever before. And some of that is because of an increase in connectivity. We spend more of our time interacting online. The first thing that people in California do when they feel that like their house shudder is they connect to their favorite social media site these days and ask if there's been an earthquake of people they don't know. And so we've got a lot more communication. It's easier to find people who might have the same problems that you do. And so it makes it more apparent when things aren't working the way that you expect. And instead of just kind of internalizing, oh, it must be just me, we go out and we find other people for which things aren't working. And we say, okay, well, there's an issue here. And that's really apparent when data breaches happen, right? Because now we've got a bunch of people having real harm done to their identity, to their financials, to their practical day-to-day life. And that leads to people and people responsible for those people wanting to implement more oversight into these public failures and their root causes. So in the European Union, we have the Cybersecurity Resiliency Act. And in the United States, we have the proposed Securing Open Source Software Act that are trying to implement some of this oversight to protect people. So let's take a look at some open source supply chain case studies. These are case studies that have spanned a number of years. And some may be familiar and some may not. So Heartbleed. Who remembers Heartbleed? I say that like this isn't a recording. So Heartbleed was a security flaw that was identified, I believe, in 2012. Or sorry, it was first introduced in 2012 and disclosed 2 years later in 2014. So it was an issue with the most popular open source cryptography library at the time called Openssl. And what it did was it made user-entered data vulnerable to being captured by malicious third parties. And with that data, bad actors could impersonate users, compromising even more information and security. It affected, at minimum, 66% of the internet, including government databases. And it was known that it was being exploited by state actors. So, this was a huge, huge deal at the time. And if you talk to engineers who were around and practicing in 2014, you can hear some of their horror stories. But it was one of the first things where people said, okay, how can we prevent another Heartbleed? How can we prevent this from affecting so many people who usually aren't exposed to flaws in open source? And before I go any further, I do want to say, like, these case studies, these cases are real, but we're looking at them from kind of a dispassionate point of view. There's no blame being allocated here. So let's just look at them as things to learn from. LeftPad might be a little bit more well-known for folks, but the story behind it might not be. So LeftPad was an incident that happened in 2016. And LeftPad was is the package name involved. So in 2016, there was a trademark disagreement over an NPM package name. And that package name was not LeftPad. So when this complaint was filed with the registry, NPM, which was then and is still privately held, NPM sided with the trademark holder and not the maintainer. As a response to that, the maintainer deleted all of his NPM packages from the registry, including LeftPad. And this is how we found out how many people relied on LeftPad, directly or as a transitive dependency. And because of how NPM references dependencies, this caused widespread failure in the NPM ecosystem, crashing popular websites and services. And in response, NPM restored a version of the unpublished package in an effort to undo some of this widespread failure. They did so without the maintainer's consent. Atomic Rights was a bit more recent. So Atomic Rights was a very widely used Python package. And I don't know the intricate details of exactly what it did, because that's not the point. The point is that at the time, PyPI, the Python package index, wanted to shore up security for its most widely used packages. And so what they did was they started to mandate that maintainers of critical projects for some definition of critical. It was, I think, based on download count and dependency count. It rolled out two-factor authentication requirements for maintainers. And I have a lot of sympathy here because I've had to do something similar, and know how difficult it can be. They did offer a couple of incentives, security keys to these maintainers, but they also said that, if you don't enable 2FA, you're not going to be able to update your project in the registry. There was kind of a mixed reception to this. But notably, the maintainer of atomic rights was concerned. It didn't really agree with the motivation and the precedent of this initiative. It wasn't saying that security's bad. It's just saying that, well, okay, what makes it so that other people can ask something of me when I'm already giving my time and my effort? And so what the maintainer did was deleted all versions of atomic rights from the Python package index. I believe he only meant to delete one of them, but it wound up deleting all of them. And the last case that we'll talk about is Node IPC. So this is a Node package, and the maintainer of Node IPC at the start of the Russia-Ukraine war created a package, a module called Peace Not War, that simply created a text file and opened it up. And that text file contained this message of peace. It was non-destructive. Maybe if you were running low on disk space, it could have been construed as destructive, but it was pretty low impact. However, the maintainer of Peace Not War added it as a dependency to Node IPC, which was extremely popular, with 1 million downloads a week at the time. And what this would do, it would only target users of the package who were based, or systems based in Russia and Belarus, and it would overwrite files on those systems. It would also display the message that was contained in the Peace Not War package. But any package that depended on it would be affected if they did not pin their dependencies. The most notable of which was Vue.js. And this type of event, or this type of you can't call it a vulnerability necessarily, but it's called protestware. This was not the first, and it wasn't the last, and it will not be the last. So the question becomes, to me, when I think about them, is, are these problems in the software supply chain as we understand it? And it deserves some careful consideration. Because at first gloss, it does, right? But let's reframe the conversation a little bit. Software is a complex system. And complex systems are unpredictable, but they're constrained by rules that introduce order. So, if all of these shapes are elements in software's complex system, we have components that interact in multiple ways, following local rules, with no unifying rule to define all of the interactions. And the emergent system is greater than the sum of its parts. And if we look at those cases through the lens of complexity theory, we can look at it a little bit more closely. So for Heartbleed, yes, there was a bug. Again, introduced in 2012, publicly disclosed in 2014. There's a real vulnerability there. But it also revealed an underlying issue, which was that Openssl was effectively being maintained by one person. Arguably two if you looked at it in the right light. That maintainer had a full-time job, did not have the bandwidth to drop everything. I'm sorry, bandwidth is the wrong word. Did not have the ability to drop everything, take an unpaid leave to go and fix Openssl. And this revealed that just how many, including billion-dollar companies, were relying on the unpaid labor of this person who was maintaining Openssl in their spare time. So open source may be distributed, which is one of the things that we say when we say open source is amazing and stable and secure, but maintainership isn't necessarily. When we look at LeftPad, was the root cause technical? No, it wasn't. It wasn't technical at all. And if we looked at it, it wasn't even a legal one with LeftPad. It was a legal one with an unrelated node module that happened to be maintained by the same person as LeftPad. And so it was caused by this completely unrelated to LeftPad dispute between three private parties. Consumers of LeftPad would have no way of knowing that this was a risk at all. And it had such a widespread effect across the internet. And so conflict between some very human conflict and maybe business conflict can have very real effects on what seem to be unrelated parts of the open source software supply chain. when we look at atomic rights, we have, again, two entities, the maintainer and the package registry, who both believe that they're doing the right thing. They're working with different sets of priorities. They have a fundamental misalignment in what they want to do. And when, if you work in stakeholder management at all, which is also one of the things that I can add to my list of many hats, this is not an uncommon situation, and especially so in open source. And there's also a differing opinion of what your role and obligation is within open source. On the one hand, increasing security makes perfect sense. Again, I was part of an effort to do similar. Also, not further burdening already overburdened maintainers also makes sense. It's just two different perspectives, two different priorities. And what happened. And it reveals that even when we think we are trying to improve the supply chain, there can be unintended consequences from those efforts. And we have to acknowledge that the system that we are working within is again, a complex system. Finally, with Node IPC, look, we talk about open source being a phenomenon that spans geographies, that doesn't respect or isn't confined by borders. It's a global ecosystem. But it's only partially true. Open source is still subject to laws, regulations, and resources. And I've talked with enough lawyers to know this gets very complicated very, very rapidly. Even outside of the code, the artifact itself, the people and participants aren't in this ephemeral global ecosystem. I mean, they are, but they have to live somewhere or reside somewhere. And so when you're talking to people within these global open source ecosystems, we have to consider that they're still affected by sanctions, censorship, war. We don't exist in a vacuum, and the technology that we create doesn't either. So it's not just a complex system. The system that produces software is a complex sociotechnical system. We have people in the mix that you can't separate out of the overall system. They're inextricably linked. And when we think about this supply chain, the efforts within the supply chain, open source, etc., we need to ensure that we account for the interactions between our society's complex structures and the behaviors of the people who live within them. So in case you need a pretty slide with that, the system that produces software is a complex sociotechnical system. You can't abstract people out of the supply chain. You can't build tooling to solve for people. Some quotes, because they're just too powerful not to have them in here. And this is actually from Marcus, the maintainer of atomic rights. Wrote in an issue, because I thought that was an annoying and entitled move in order to guarantee SOC 2 compliance for a handful of companies at the expense of my free time, I deleted the package and published a new version. Marcus would later go on to archive atomic rights. Jeff Geerling wrote a fantastic blog post about his experiences being a maintainer and setting boundaries around it. And he wrote, I have a family, and I have a chronic illness, and I have to maintain some semblance of work-life balance. The problem is, users don't understand my project goals or life situation. Not that I expect them to. But some of these users and potential contributors take offense when an issue they post or a PR they toss over rots for a few months, eventually gets marked stale, and gets closed. Tidelift's own maintainer survey says that 59% of maintainers we surveyed have quit or considered quitting maintaining a project. The amount of time and stress involved in maintaining projects isn't balanced by the rewards. In a paper, a research paper published a few years ago, given open source's asymmetry, high stakes, and the lack of a contractual relationship, users that demand changes from the project, be it additional features, specific changes, e.g. perceived bugs or limitations, or better documentation, may be perceived as entitled. A later paper says, in a space where, despite increasing professionalization and commercial influence, still the majority of participants volunteer their time, reports abound from open source maintainers about stress, burnout, or even complete disengagement due to toxic interactions. And finally, Nolan Lawson put words to something far better than I could ever. And that's, if there's one thing I've learned in open source, it's this. The more work you do, the more work gets asked of you. There is no solution to that problem that I'm aware of. So when we think about the open source software supply chain, We have to understand that they're affecting this socio-technical ecosystem. And we have to keep humans in the forefront of our minds when we're trying to improve this ecosystem. Because even well-meaning ones can affect the ecosystem for years to come. How we treat others is an open source supply chain issue. Understanding each other is an open source supply chain issue. Understanding our environment, understanding our users, it's all an open source supply chain issue. Open source doesn't exist in a vacuum. The technology that builds on top of it doesn't exist in a vacuum. We all are humans here. So, you're part of the supply chain. Each and every person that is here at Upstream today is watching the video later. People who don't watch the video later, good job, you're part of the supply chain. And when we're building technology, when we're commenting on issues or pull requests or submitting our own, we need to consider all people as critical in and to the software supply chain. So some references for your later perusal. And with that, I will close and say thank you for having me and being humans in this supply chain. Again, you can find the link to this. You can find these slides at bit.ly/humans-in-supply-chain. Thank you so much.